Okay, thank you. Ladies and gentlemen, let's talk about the future role of green gases, not only in V4. Uh, why to think about green gases? To put it in simple, in future we have to replace from different reasons imported natural gas as much as possible, as well as to decarbonize existing hydrogen production. And green gases, especially green hydrogen and biomethane, could be or are the main way how to replace mentioned fuels. So let's begin with the current situation. Uh, on this on this slide, you can see the current production capacity and annual production of hydrogen in V4 countries. As you probably know, there are different kinds of hydrogen. I mean, from chemical perspective, it's still the hydrogen, but there are different ways how to produce it. What you can see is the most complex color scale which I was able to find of the hydrogen, including white hydrogen, green hydrogen, or different shades. When we are talking about current hydrogen production, we need to also talk what are the existing ways we are using to produce hydrogen. When we check the situation in EU, we can see that more than 90% of current hydrogen production is provided by steam reforming based on a natural gas. And only 0.2% is provided by reforming with carbon capture, and 0.3% is provided by water electrolysis. That's the situation in EU, and when we check the situation in V4, we can see that it's similar. More than 90% is provided by reforming. Small fraction is represented by byproduct production. But in 2022, from when this data are from the European Hydrogen Observatory, we can see that in V4 there were almost no CCS nor electrolysis projects which are able to produce green or some form of low carbon hydrogen. So that means that we have to replace not only mentioned natural gas, but we have to switch the current hydrogen production to some low carbon variant, to low carbon alternative. What are the plans for the hydrogen? You can see the chart showing the national hydrogen strategies and their objectives for 2030. In Czech Republic, there is a plan to have from between 3 to 400 megawatt electrolyzer capacity with utilization between 30 and 50%. And the utilization actually depends on the renewable resources which will be used for such a production. If it will be only some photovoltaic or some combination of different resources, depends on the specific installation. In Hungary, there is not only plan for electrolyzer capacity, but also there are mentioned objectives for the green or low carbon hydrogen. And you can compare it with current production, which is like actually 10 times higher than those objectives. In Poland and in Slovakia, there are again some plans for electrolyzer capacity. Those are hydrogen strategies, But as I mentioned at the beginning of this presentation, hydrogen or green hydrogen is not the only existing low carbon gas. Another available gas could be biomethane, which could be produced by different techniques like anaerobic digestion or thermal gasification from different sources. You can see their list on this slide, and on next slides you can see the outputs from the study from 2022 prepared by European Biogas Association, showing the potential for 2030 and 2050. In this case, we are talking about anaerobic digestion, when we can see that the biggest potential is related with animal manure and agricultural residues in 2030. And in 2050, the biggest share is represented by sequential crops. Please don't ask me on the details because I'm not familiar too closely with the topic of agricultural production, but it's related with how to describe with switching of the crops on the same field. So it's actually biomass plant by purpose for such a way of utilization. On the other hand, the thermal gasification has also some potential, but when you check the scale, the values in BCM, you can see that it's actually not really comparable with the anaerobic digestion potential. So that was thermal gasification potential for 2030 and for 2050. Anyway, here you can see it in one complex chart. And you can see that the potential in 2050 is actually quite significant. To put it in the graph, you can see that the long-term potential is much higher than the near-term one. But what is, I guess, more important is to compare this potential with the current natural gas consumption. So, according to a quoted study in Czech Republic, Hungary, and Poland, in a time frame of next 25 years, we are potentially able to replace around 50, in the case of Poland, more than 50% of current consumption of natural gas by biomethane. That means actually that that's the estimated potential. Other question is how we will be able to fulfill those numbers. The rest of the future need for low carbon gases should be or must be then covered by imported green hydrogen or some different low carbon forms of hydrogen which are not emitting CO2 into the atmosphere, or the same way we can actually use the natural gas in combination with CCSU if this technology will be available in such a time scale. Maybe a short note to previous discussion. The deployment of this technology actually depends not only on some technical development, but it's also kind of site-specific because you need to have some underground storage, and not every areas are suitable for such a purposes. So just to remind that there are also other sources for green hydrogen than in the Europe. So in the future, there is huge potential worldwide. So there for sure there will be available some green hydrogen. Another thing is how to transport this hydrogen into V4 countries, into Central Europe. What you can see on this slide is a map showing the European hydrogen backbone. The Poland is in gray color because, as far as I know, Poland is not the member country of this initiative. But you can see that there are existing plans, not based on some new pipes, but mostly, as far as I know, those plans are connected with reusing of existing natural gas infrastructure. Maybe later on, my colleagues will discuss this in the panel discussion. Of course, one thing is production, and another and really important thing is demand side. We have to think about the structure of current and future consumption of all of mentioned gases. We also have to think about energy saving potential, and on the one hand, and on the increased consumption of low carbon gases in relation with decarbonization of hard to abate sectors, like the industry of or some part of transportation. That means that we have to think not only about how we get green gases, but we have to think a lot about some strategic use of such gases across different sectors. When I talk about structure of current consumption, I mean that if you check the current situation in Czech Republic, we are using natural gas mostly for space heating. Like the almost half of current natural gas consumption is related with the consumption of the heat in companies. Like half of this heat is process heat, but the second half is related to space heating. So together with production of heat in households, we are talking about approximately half of the current consumption of natural gas is used for heating, which is maybe again not the best way how to use this fuel, to just burn it in the boiler in the stove with efficiency less than smaller than 100%, when we could use this fuel, for example, to balance electricity production, to increase the possible penetration of renewables into electricity grid, and to produce electricity, which then could be used for space heating with the heat pumps with efficiency several times higher than compared to current gas used. So the last slide is showing the one of the outputs of the Austrian hydrogen strategy, which is showing some preferred strategic use of in this case green hydrogen, showing that, for example, for individual heating, it's definitely not the best way. In area of transportation, in the sector of transportation, the same is to use hydrogen for some personal cars. In the case of some trucks and buses, means this depends a lot on the on the profile of use of such trucks and buses, because we can observe increasing possibilities of battery technology of electric vehicles. But of course, in case of aviation, there is really limited use of batteries, and when we are talking about some long-haul flights, then there is no other way than to use hydrogen in the form of some cryogenic fuel. In industry, it's similar. When we are talking about some low temperature heat, it's not necessary to use such a valid fuel like green hydrogen is, or other green gases, when we are able to use some high temperature heat pumps. But of course, in the case of, for example, steel production or chemical industry, there are actually no other ways than to replace current technologies by this green hydrogen or its alternatives. So that was a short introduction, and now some questions for discussion. The thing is, what is actually realistic potential of biomethane production, comparing the numbers I presented? What is the future potential of green hydrogen? And I'm talking about the local production versus imported green hydrogen, and its application across different sectors, which is related, of course, with the options for import from not only Europe, from the countries where they have better conditions for renewables, but also from other countries overseas, for example. So at this moment, thank you for attention, and I'm looking forward to the discussion.